looking at defining chemistry. So when we look at chemistry, it's the science of looking at different transformations of matter. So when we use the term matter, it's basically by definition is anything that occupies space, right? So now when we using the term energy, and by definition, energy is the capacity to perform work. So when we think of energy, that include things like light, heat, electricity, motion. Now, when we deal with chemistry, it's just looking at transformation or transformation from one form into another, from light to heat, or and so on, right? So now, like light energy, for example, would be like converting light into chemical energy, and that would be by photosynthesis, which we'll talk about later. Chemical energy include things like motion and heat. So one application of chemical energy is cellular respiration. Once again, we'll talk about that later on. So life depends on constant energy transformation to build and grow and maintain complex systems. Okay, so like I mentioned before, I did define what matter is, and that includes anything that has mass and takes up space. So, for example, even air is composed of matter. So, if you actually grab your hand and if you go and swing your arm back and forth, so even though you don't visually see the air, you could feel like there's this that occupies something. There's something there as you move your arm back and forth, right? So now matter on Earth, for example, has three different states. So matter could be found in the form of a solid, right, a liquid, or a gas. Later on, we're going to learn why water is so essential and important to life, because water is one of those things that we could find it either as a solid, a liquid, and a gas. Okay, so now the next question is, what makes up matter, right? So anything that occupies space, yes, but what are the components, what are the building blocks of matter? And that we're looking at specific atoms. So atoms, by definition, an atom is the basic structure unit of matter. Now we're going to get into a little bit more detail. Now we're going to go ahead and look at atoms and see the composition of what is an atom and what is it made of. So atoms are composed of protons, neutrons, and electrons. And then we're going to talk about a little bit of like the charges, their locations, and so on in the next few slides. Okay, so now that we define what chemistry is, what matter is, what an atom is, the next definition is looking at what an element is. So an element is a pure substance that cannot be broken down into simpler substances by any chemical reaction. So if you look at the periodic table, there are 92 naturally occurring elements. And each element in the periodic table is going to have a symbol. So, for example, and depending on the root of the element, so some of them are like Latin roots associated with it, some of them English roots. So, for example, the abbreviation for hydrogen is going to be H. The abbreviation for carbon is C. The abbreviation for nitrogen is N. The abbreviation for oxygen, O, and sulfur is S. However, sometimes there are abbreviations. So, for example, if you have sodium, like the abbreviation is Na. So then you're like, if you put sodium for S, right? So then you would be wrong because the S is the abbreviation for sulfur and not sodium. So it just depends. If it has a Latin root, then not necessarily the first capital letter doesn't match the abbreviation. So of course, in this class, you don't have to memorize all the different abbreviations in the periodic table. you probably have to just memorize the ones that we actually talk about in the class. Okay, so one of the interesting things is that just a few elements make up most of the living world. So these are considered to be the basic building blocks that combine in different ways to create so much diversity. So again, it doesn't matter if we're looking at something so simple like a bacteria cell or all the way down to a mammal, in this case a whale. Life is basically made from a handful of specific elements. So this is what the periodic table looks like. And sometimes, yes, it could look very intimidating because you see that you have different abbreviations. Like I said, just depends if it's a Latin root or not. So for example, iron, the abbreviation for iron is Fe and not I, right? So it just depends on where the origin is of that specific element. Okay, so once again, so these basic building blocks, they contribute to a lot of the different biodiversity that we have on Earth, and that includes hydrogen, carbon, nitrogen, oxygen, sulfur, and phosphorus. Okay, so now looking at the periodic table, so there's a lot of information that you could get from here. We could look at the atomic mass, we could look at the atomic number, we could look at is it a metal, is it a non-metal, and everything is color coded. And if you're just looking at the periodic table, like I said before, it could be a little bit intimidating. However, I'm going to teach you how to read the different components. And again, we're not going to go into so much detail because this is not a chemistry course. However, we're going to go into enough detail of like the concepts of the periodic table that apply to understanding future biological molecules. Okay, so we'll come back to the periodic table, but let's go now. There are other, so like I did mention before, there are 92 naturally occurring elements, and 25 out of those naturally occurring elements happen to be essential to like humans, for example. So for example, four of those elements make up 96% of the weight of the body, and within our body we have other elements that they call trace elements. So trace elements, what they are, they require in very small amounts, but they're essential. So if you happen to be like, let's say your body is missing some of these trace elements, sometimes there's side effects to that. So here is an example of an individual with a side effect because it's missing one of those trace elements, and that specific trace element happened to be iodine. So this individual is missing iodine in her body, and because of that, it has a side effect, which is a goiter. So where can you find iodine? Well, you find iodine in salt, right? So again, is it naturally in the NaCl molecule? No, it's supplemented. So sometimes you have regular salt and they add iodine to it as a supplement. Now, iodine is naturally found in things like eggs and strawberries and milk. So they require in our body, but by small amounts. So if you look at the composition, this is a picture of the human body, and notice that you're going to see the different elements, like what percentage of carbon is found in your body. So for example, 18.5% of your body composition is carbon. If you look at calcium, it's like 1.5%, phosphorus, potassium, sulfur, sodium, chlorine, magnesium. So those basically hydrogen, nitrogen make up some of the composition within your body, right? So that would be, these are elements found within your body. Now, if you notice, also within your body, you have trace elements, but notice that the trace elements, they're found in very small amounts. So that individual that had the goiter is because the individual had an iodine deficiency. So for some reason, that individual is missing the percentage necessary in your body, which is this iodine that could be found in dietary supplements like milk and strawberries and eggs, or if it's supplemented in your regular salt. So because of that, there's a side effect. So trace elements are required, right, in only very small amounts, and they're essential for life. Okay, so now elements can combine to form compounds, right? So what is a compound? So new substances made of two or more elements in a fixed ratio. So here's some examples of common compounds. Like for example, if you have your table salt, so table salt is a combination of two different elements. You're going to have your sodium, which is Na, and Cl is your chlorine or chloride. So together is sodium chloride, and that is your regular table salt. Another common compound is going to be H2O, which is water. So this is a combination of hydrogen and oxygen. So once again, compounds by definitions, they happen to be made out of two or more elements in a fixed ratio. So these compounds have very different properties from the elements they're made of once they come together. So like I said before, atoms, so each element is made out of one type of atom. So an atom happens to be the smallest unit of matter, like we said earlier, that still retains the chemical properties of that specific element. So even the most complex living systems are built from combinations of just a few types of atoms. We did mention before, the hydrogen, carbon, nitrogen, oxygen, sulfur, and phosphorus. Okay, so now we're gonna go ahead and dive in and look at what the composition of atoms are. And atoms themselves are composed of what we call subatomic particles. Okay, so now we're going to go ahead and dive in, and we're going to see what is the composition of these subatomic particles within the atom. So let me show you a picture. So here, this is the subatomic particles. So atoms themselves, this is looking specifically at helium. But if you notice in this picture, the subatomic particles of an atom, it includes protons, neutrons, and electrons. So if you want to answer and say, what are the subatomic particles of an atom, then you would say one are going to be protons, neutrons, and electrons. Okay, so now that we know that the subatomic particles of an atom is a composition of protons, neutrons, and electrons, now the next question is understanding where these subatomic particles, where they're found within the atom. Okay, so in the center of an atom, there is a nucleus. And two components are found within the nucleus of an atom, and that includes protons and neutrons. So if you're looking at an atom and you want to find out where protons and neutrons, you want to find their location, then they're going to be the nucleus. Now, there's another component, the last subatomic particle is electrons, and electrons are found within an atom in a location called the electron cloud. And that's exactly what you see in this picture. Now, you may wonder exactly where is this cloud. So this cloud is like exactly how you see it in this picture. It's like this cloud. There's no, like, if I'm gonna find helium, I can never pinpoint where the electron is, because it's in this electron cloud, they move so fast that by the time I pinpoint, is somewhere else within this cloud. So sometimes we're gonna have to visualize them exactly their location. So sometimes we represent them not in an electron cloud, but instead we represent them in an electron, and I'm just gonna abbreviate electron like this, an electron shell. I'm gonna show you later on like the electron shells or electron configurations of their locations of where these electrons are found. So now the question is location. The subatomic particles that we talked about, they're either, if we're talking about protons and neutrons, they're found in the nucleus. If we're talking about the location of electrons, they're found either, I could say, an electron cloud or an electron shell. Okay, so another important thing to take into account is charge. So protons, as you could tell in this picture, protons are always going to have a positive charge. So think of like P for positive. Neutrons, think of N for neutral. They have no charge, so they're not positive nor negative. So there's no charge on them. And then we have was the following component, which are electrons. Think of like electronegativity. So there's an electron, they're negative. So they have a negative charge. So positive for protons, negative for electrons, and neutral for neutrons. So there's no charge in them. So this matters because that's going to tell us a lot about their relationships and bonds that they would make with other atoms or other